Hi, everybody. Welcome to TGCS. My name is Tim Gallagher, and today we are going to be discussing AP Computer Science A, Topic 4.9, ArrayList Traversals. And in the second video, we're going to develop code used to traverse the elements of an array list and determine the results of those traversals. We'll also explore the special techniques required to avoid skipping elements when deleting from an array list. Let's get started. So here we have the beginning of a program where we declare an array list of integers called myNumbers. We're going to populate the array list with integers, but we're not going to have the code for that here. Let's assume that it gets filled with integers. The first thing we're going to do is print out the array list. Now, the array list class has a toString method that will give us a string representation of our array list to print out. Next, we'll have a for loop to traverse over our entire array list. In the body of the for loop, let's do something other than just printing out the elements like we did in the previous video. Here, let's check to see if an element of myNumbers is greater than 30. And if it is, we're going to remove that element from the array list at that particular index using the remove method. Finally, we'll print the contents of myNumbers again to compare it to our original array list. All right, so let's run our code. Here we create an array list of integers called myNumbers. And let's assume we populate the array list with these integers. Now, we're going to utilize the toString method of the array list to print out our array list, and we have our 7 numbers printed. We enter our for loop, and I is initialized to 0. We now come to our conditional, and we check to see if the element at index 0 is greater than 30. 12 is not greater than 30, so nothing happens. I now increments to 1, and we evaluate the element at index 1. 42 is greater than 30. So we remove that element. Now, remember, when an element is removed from an array list, the remaining elements all shift 1 index to the left. Now, I increments to 2. 92 is also greater than 30. So it gets removed. And again, the remaining elements shift to the left. I now increments to 3. And 8 not greater than 30, so nothing happens during this iteration. I finally increments to 4, and 22 is not greater than 30, so nothing happens on this iteration either. So our loop is now complete. And the last thing we'll do is print out the array list again. And you can see that some of the numbers have been removed according to the if statement in the body of our for loop. But wait a minute, why is 38 still in our array list? How did that value evade our remove method? Let's recap a portion of what happened here. So when I was 2, if you recall, the element at index 2, which was the integer 92, 92 was greater than 30, so we removed it. The rest of the elements then shifted to the left, and this put 38 in the location where 92 used to be. But now we go back up to the top of the loop, and I increments to 3, which means the next element we visit is at index 3, which is the 8. And we've totally skipped over the value 38. So our algorithm won't work properly if we're skipping over values. All right, so how can we fix this? Well, there's a few different ways, but let's look at 2 different solutions. First, we can fix this by making one small addition to our existing code. Every time we remove an element, we're going to do an I minus minus, which will decrement I back 1 position. This will allow us to evaluate the new element that shifted into the deleted element's position. We won't skip over any elements that shifted left. Let's look at how this works. So previously, when we did the recap here, when 38 was skipped over, it moved into index position number 2. And when I incremented to 3, the next element that was evaluated was an 8. But now, if we do the I minus minus as we remove an element, I was decremented back to 1. So when we go back up to our top of our iteration, I is now going to be incremented to 2, and the element that was shifted into 2, 38, gets evaluated. So now no elements get skipped. So now when I execute this code, there we can see that all the elements that were greater than 30 have been removed, including 38. All right, let's look at another solution. If we take our original code, but this time I'm going to traverse the array list backwards, starting at size minus 1 and traversing down to 0. Now, when the elements shift to the left, when we remove a value, the elements that shift are ones that we've already evaluated, so no elements get skipped. Let's look at how this works. So we're going to start here with the array index of 6 because that is my numbers.size minus 1. 6 is not greater than 30, so nothing's going to happen. 8, which is the next element that gets evaluated here, is also not greater than 30. So again, nothing happens. But now 38 is greater than 30. So what's going to happen when I remove this value? Everything shifts down. But look, we've already evaluated 8. We don't need to worry about that one. So now I is going to be 3. 92 also greater than 30. Everything shifts down when 92 gets deleted. 17, not greater than 30 when I is 2. So we're going to move on. I is now 1. 42 is greater than 30. So it gets deleted. Everything gets shifted down. But again, we don't skip any elements. And finally, 12 is evaluated at index 0. And 12 is not greater than 30. So that doesn't get removed either. And now when I print the numbers, we can see that all elements greater than 30 have also been removed from the array list. So today we developed code used to traverse elements of the array list and looked at the results of those traversals. And we also explored the special techniques required to avoid skipping elements when deleting from an array list, such as subtracting one from our index each time we remove, or traversing the array list in reverse order. All right, that's it for this video. Thank you so much for joining us here today. Don't forget to hit that like button, subscribe to this channel, and we'll see you next time. Take care.